Hello, Paul Hamler here. Welcome back to Paul Hamler's YouTube channel. I think we got a nice little video today here on a topic that's been covered quite a bit over the years, and that is making wooden screw threads. I first started making wooden screw threads about 40 years ago. Here I have I think it's volume 1, number 6 copy of the original Fine Woodworking magazine. It had an excellent article. It's about a 4 or 5 page article on making wooden threads. And the focus and the emphasis, like so many people have done, was based on the old antique tap that had a kerf in the body and a blade that rode into the kerf, and you would drill your minor diameter of your stock that you wanted to thread, mount it to the back here, clamp it, and there's a tap that extrudes here. As you turned it, it would go through, it would follow the pitch of the tap that's set in on the angle here, and the cutter would go in and literally scrape out the inside and form your nut. Now, you could also use this fixture for making your nuts, but primarily the reason you would build something like this, you could pick up the pitch of the thread that you wanted to manufacture, and you would make a blank that you could later convert into what we refer to as a screw box. Now, having tapped the inside threads of this screw box with the tap, the next step was to mount a V-type cutter inside. And you would typically have to route it out, dado it out with a router, and insert that cutter, and the alignment had to be very precision in the fact that the apex of the cutter had to ride right on one of the high spots of the internal threads. Alignment and setting the cutter on this type of box was very troublesome, but yet it was done for years. Matter of fact, here is an antique screw box type that has the internal V cutter in it, and it's dadoed out and mounted inside, and it's got a little retainer nut that holds the cutter in place. When I started making screw threads, I was doing a lot of antique pair restoration. Antique plow plane restoration, repairing the broken arms and broken nuts. And the challenge that you get into when you're dealing with antique plow planes and screw arm type plow planes, every manufacturer or every plane maker, he had his own unique screw box. There was, this was before threads got standardized and everybody had a standard pitch. So you could not make a screw box to use for a particular plane and transfer it over to 2 or 3 other makers. They were typically always custom made and different. So when I started making wooden thread fixtures, what I was trying to do was come up with a way of making a screw box that was universal, that would not only do different size threads, but it would also do right-handed and left-handed threads. And in a minute we'll get to it, and I'll show you the fixture I designed and built for doing threads as small as 3/16. The largest I've done is 1.25 inches. The fixture also enables you to use, if you have a plow plane, a broken arm or a nut, all you need is one good nut and at least 3 or 4 inches of threads on an existing arm. If you have that, using my fixture, and I'll also show you a way to accomplish this feat on a regular metal lathe, just using the metal lathe as a holding fixture. But with that, you can reproduce Typically the way I go about it, I will reproduce using what I have left of the arm and a nut. I will make a new nut, and then that nut will later become the body for a screw box. So I can make the nut using the original pitch and measurements on the antique plow plane, make a body with that same pitch and thread size in a blank for a screw box, and then I put a cutter in it, and now I've got a screw box that will match the original thread size and pitch of the plane that I'm repairing. The original, just for a little history on the plow planes, here's a picture, an original, what we refer to as a captive arm plane. It's got these captive wedges that you can loosen and adjust your distance of the cutter and the fence for your cut. That was the early style, and then later on, when they started putting, that was your basic model. When they went to the screw arms, in order to adjust the distance from the cutter to the side of the fence, you had to loosen each individual nut, tighten up the washer. It was one arm, then back to the other, back and forth to get it aligned. Well, this worked good for several years until Sandusky, tool company up in Sandusky, Ohio, came up with the improved version of a plow plane. We commonly refer to it as a center wheel plow. This particular plow here is a reproduction that was made by a good friend of mine. He's now deceased, Bob Baker. And Bob and I collaborated on some of the fixtures that we came up with here. And what was unique about this guy, with the center arm plow, you had one wheel that you could turn. You had left-handed threads over here in the bridge that connects to the two arms, and then in the body you had right-handed threads. So by turning the center wheel, you could move the fence, and then once you got it locked or positioned, you had two thumb screws here that you would lock in to prevent movement. This was a very, very nice improvement over the adjustment mechanism in the earlier plows. And of course, when I started making miniature antique tools, I had to make a center wheel. This is one of my first examples here. We'll set these and get a close-up of them where you can get a better view of them here in just a minute when I move the camera. But anyways, again, going back to the development of the box that we're going to talk about, it was a compilation of different ideas that had been tried over the years. One of the advantages of the box that I designed and going to use, if you're going to make a screw box, one of the shortcomings is always you've got to tap the inside of your box so that once the cutter starts cutting the threads, they will track inside and guide it to maintain the desired pitch. Here's an example of an English small screw box. There's a V cutter inside here, and this is your cutting the external threads. Here we go. The tap that came with this threading cutter was a design that was used pretty commonly. Here's a larger tap. We'll put the two side by side. And this is something that's relatively easily made on the metal lathe. You just thread the pitch of your screws. You bore a hole in the end and then drill a hole right in front of one of your high spots on the thread. As this thing rotates around, it cuts and scrapes out the chips for the internal threads, and they fall in the hole and keeps it from jamming up. They're pretty effective. I've made several of them, even well, here's one I made is a lot smaller version, and same design. and we'll put these side by side and get some photographs of them. So what we're going to do here is, again, we're going to focus on the box that I designed for doing these small and large threads, right-handed and left-handed, but we're also going to break out and go over to a couple of different setups on the metal lathe that will help you you know, do different wood threading techniques for different special situations. We'll also show a tap that's a little simpler to make than this mechanism here. Now, most of the presentation and focus is going to be on using a V-cutter like was used in the screw box for cutting the threads. For all practical purposes, just refer to this, think of this V-cutter as a V-gouge with a 60-degree included angle. Now, in order for any of these mechanisms to work, whether you use it on the lathe or in my screw box, or if you're going to make a custom screw box, in order for it to work, it is imperative that you understand how to sharpen this cutter and get this cutter where it will talk to you, so to speak. In just a minute, I'm going to move the camera. We're going to get a close-up. I'm going to show you 3 cutters here. One of them, this is a cutter that I made over 40 years ago from a blank piece of 012 steel. It was filed and stoned and sanded to sculpt that V-cutter. I think it took me around 8 hours to build this cutter. A lot of filing, a lot of detail work. And then I realized that Conover Tool Company was selling a screw box kit, and you could also buy replacement cutters. So for 10 or 12 bucks, I could buy a replacement cutter and save me that 8-10 hours of filing work and stoning to get a cutter to where it would work. For the most part, their cutters out of the box, when you would order one, was very well sharpened, properly sharpened, and it would cut. I just recently ordered, and didn't realize it was still available, but from Woodcraft you can order a replacement V cutter for a screw box. Say it's almost identical to what Conover was selling 40 years ago. And I'm going to show you, I have not touched this cutter, I just took it out of the bag, and I'm going to show you why you need to understand how to sharpen these. And what I'm going to refer you back to on how to sharpen this cutter was, I think it was a couple of videos back, I did a video on how to sharpen a V-gouge without using stones. Now, since I did that video, I got to thinking, the floppy disk that I was attaching the sandpaper to with the little Velcro strips, sometimes I needed a little more solid, a more rigid backing. So I turned one down out of aluminum, just an 1/8 of an inch manual to fit in the motor tube, put the Velcro on it, and it's rigid in the fact that it's not made from the silicon floppy disk. It seems to work a little bit better doing these larger cutters. We'll get some close-ups of this as well. With that said, what we're going to do is we're going to move the camera and bring a close-up. As on the screw boxes, you got to realize when you're cutting the V-gouge or the V-cutter, the threading cutter is cutting the threads on the outside of your rod. It's cutting across the grain, and so that's why it's imperative that these cutters be extremely sharp and will cut across the grain. When I first tested my box, I would always use some really soft hardware store dowel material, and it ranged in from birch to, I don't know, all kind of exotic softwoods that they made the dowels out of. But my logic was, if I could get that cutter to cut the really soft wood You know, in some cases Abe used pine. If I could get that cutter so sharp that it would cut and thread pine, I knew it would work on the exotics, whether it be boxwood, rosewood, ebony, all of which I've made threads on. So let's move the camera and let me show you what we need to accomplish in having this cutter before you ever think about making a screw box type cutter that's going to cut with a V-gouge. The cutter on the left is one replacement cutter I recently purchased from Woodcraft, and the one in the center is a 40-year-old cutter that was purchased from Conover years ago. The one on the far right is one that I made from a piece of 01 square 2 stock and hardened and tempered it. At the top of the pencil there to the left is the silicon floppy polishing disc that I use primarily for touching up and removing any burrs from the inside of the V gouges or the V cutters. To the right is was made out of a piece of 1-inch aluminum stock turned down to a 1/8 of an inch so it would fit in the Dremel or the motor tool. It has a piece of Velcro cemented to the face of it to receive the Velcro type sanding disc. It's I think I use a 220 disc for this particular application. Okay, to start with, we've got the V-gouge that we used in the sharpening demonstration. Here we're going with the grain. Now let's go across the grain. Notice how the shavings, when you're going across the grain, kind of have a little break or symmetrical curl to it. That is goodness. Now, using the V cutter that I made from a piece of stock, 01 stock, not quite as easy to control without a handle. Make a little lighter pass here. Again, that's with the grain. Now, we want to go with wood threads. We're going to be going across the grain. So with that in mind, it should cut as crisp and clean. Notice the little curls on, or the breaking on the chips there. That's typically what you should expect when you're going across the grain. Okay, using the Conover cutter, going across the grain, no tear out. Again, looking at the chip, the formation of the little curls. That cutter will work in a screw box. Now, the cutter that I ordered from Woodcraft, the first thing that you noticed looking at the side of it, remember on the video of sharpening the V-gouge, where we basically got two chisels that come to a small point, and you treat that point as a miniature gouge. In sharpening this cutter, they've left a little tit or a stub, I don't know what you call it, that sticks out. As far as cutting with the grain, the cutter works extremely well. It'll cut all day long with the grain. However, with that little tip or nub that's hasn't been properly sharpened and formed, if I try to cut across the grain, watch what happens. You see the tear out? It's extremely difficult to get it to bite and start cutting. For all practical purposes, this cutter is useless for a screw box. You should be able to go across the grain as smooth and as crisp as going with the grain. If I have time, I will take this cutter offline and sharpen it and demonstrate how it cuts after being sharpened. Enough said. Took a minute to sharpen and touch up this Woodcraft cutter and got rid of that little tit that was sticking out there. And let's try it out here. Quite a bit of difference. Cuts extremely well. You got your chips curling out of there like they're supposed to. So now we have a cutter that will work in a screw box. Okay, here we have a couple of pair of right-handed and left-handed screws that were cut, external screws that were cut. The alternative ivory was cut on a different fixture. However, the ebony and any type of wood can be cut on this screw box. Well, let me rephrase that. Although I didn't cut the alternative ivory on this box, I'll show you later the fixture that I use for cutting it. It can be cut on this box with the addition of a power router. Okay, there's the overall view of the screw box, and what we've got is we've got a lead screw that goes through a nut through the first divider here. There's a nut inside here. This is strictly for stabilizing and keeping the lead screw stable. Have a coupling on the end of it attached to a small chuck, drill chuck, and at the end, inside of the drill chuck is just a old piece of boxwood I found laying around. It's been, part of it's been threaded, but we're going to finish cutting some threads on the uncut portion of it. The plate here is a 1/4 inch piece of steel that has a V-type threading cutter attached to it. It's currently set up for doing right-hand threads. In order to convert it to do left-handed threads, you would remove this nut and the lead screw and drop in a left-handed lead screw in this portion here. It's 4 screws, it just pops out, you put another lead screw in. In order to go from right-handed to left-handed threads on this fixture, for cutting the external threads, it's a matter of taking this plate here, this 1/4 inch plate, taking it out, turning it upside down, and sticking it in those sets of grooves that the pencil is setting on top of to change the pitch angle from right-handed to left-handed. So you've got the cutter plate has 2 cutters, one here and one on the back side. You just take it out and flip it over and put it in this set of grooves here, along with changing your lead screw to cut left-handed threads. The setup now, we'll get a close-up and actually turn and feed the the lead screw and watch the threads being cut. I'll have to position the camera to get inside where you can see it. But the tap that I use on this fixture, I just normally make them out of brass or mild tool steel. The tap diameter is equal to the minor diameter of the thread that you're cutting. I have a cutter, I have a hole drilled through and a cutter coming out, a 60-degree cutter. It's drilled and tapped to receive a set screw on the end. That's what locks in the cutter and keeps it from moving. In order to change the depth of cut on some woods, like boxwood for instance, and ivory, you can thread the internal threads with one pass and achieve the full depth of internal threads with one setting of the extending cutter. On some woods, you want to maybe take two passes so you set the depth, loosen the set screw, push the cutter back in, make a initial pass, and then take a final depth of cut pass on stubborn grain woods. Okay, we've got a piece of boxwood in there, and what I'm going to do is turn the handle and feed the lead screw. You should be able to see the chips flowing out of the V-cutter. I about used up my test stock here. So at this point, let me back it out, and then I'll show you a close-up view of the cutter and how it's attached to the plate. Okay, a little close-up of the threads portion that we just cut is between the two red magic marker areas. This was just an old test piece of stock, and this portion here had not been threaded, so we cut these threads from red to red. Now, one of the reasons I like using a screw box that uses a V cutter is you notice when the thread stopped right here at the end of the pencil point, there's a distinct geometry involved when the cutter stops at that point. You will notice that same geometry in action on the full-size plow planes where the arms have been threaded with the screw box. Now, if this had been threaded with a power router, Dremel tool, or whatever, and it was using a rotating V-type cutter to cut the threads, which is what I did on the alternative ivory, you could, it's not very distinct, but when the cut stops, you have a totally different geometry, more of a mechanical look that indicates that those threads were not cut by a V cutter or a V gouge. It's a small point, but sometimes in the miniatures, the more authentic and the more detail that you can put into the miniature to give you an idea that it was manufactured the same way as the original, it just adds a little authenticity to it. You say that word, I can't. Anyway, let's take a closer look at this box and talk about some of the features of it. Okay, again, here's the plate that holds two V gouges. This side here is for doing right-handed threads. You drop it down into the pitch for the right hand. You take it out, turn it upside down, drop it over into the left-handed pitch, and now by changing your lead screw to a left-handed lead screw, you have the capability of cutting both the right-handed and the left-handed threads, which was done on this piece of ebony. One of the advantages of having this open box concept is the cutter. If in a screw box, the cutter positioning and placement over the hole is extremely critical. With the strap holder here, you can loosen it and articulate and turn that cutter and experiment and find the sweet spot. In effect, it should be the center line of that hole should dissect the cutter in half and right on the tangent of the minor diameter. It's a very critical adjustment. Again, one of the reasons making the screw box and putting the cutter placement is a very tedious operation. With this fixture here, this concept, it's a matter of just loosening the two screws and turning it until you find that sweet spot where it cuts like it's supposed to, and then you can scribe a line on the steel plate for once you take the cutter out, you can put it back in and get pretty darn close to where you were at to start with. You notice the lower hole, the top hole is a 1/4 inch for doing a 1/4 inch threads. The right hand has a white Delrin bushing, and that's a sizing bushing where I reduce the hole size from a 1/4 inch down to 3/16 of an inch. So you have the feasibility in this type of setup to make that hole, say, as large as your box will accommodate for, and say up to a 1 inch diameter thread. You make that hole 1 inch, and then by using a series of step bushings, you plug them in there and downsize it to whatever OD thread that you wish to thread. The slotted screws on the bottom, there's 2 of them. Those were put in there for another fixture we'll look at here in a minute, where this plate can be used on another fixture for turning threads as well as in the box. Now, let's talk about one of the, well, before we do that, let's look at the setup for doing internal threads. As I pointed out earlier, here's one of the taps. You make the tap the same diameter as your minor diameter. It's got the little cutter in there and a set screw at the end that holds the cutter. Here's the plate that you would mount the piece that you're going to tap, the internal threads. Currently we have a plow plane body where the inside has to be tapped with right-handed threads. Using this alignment fixture, you go through and you position the center hole and align the hole in the nut or the body or whatever you're going to tap. Once you get it aligned, you tighten your 2 set screws and remove this. At that point, for a tapping operation, there's a set of dados here that your nut or your piece that you're going to tap drops down there at 90 degrees, and on the end of your threaded screw, in this case here, the chuck is taking up too much room, so there you can make adapters, couplings, whatever, or you can also move the stabilizing bar back to get the clearance. As far as that goes, you could cut other 90-degree dados to accommodate the size cutter that you were going to use. The One of the advantages of this box, you can kind of build it around whatever size that you think you're going to be working in. This one was primarily made for small, although I've done, again, almost a 7/8 inch diameter threads on this box. And what I do, if you can envision this, let's say we had a plow plane arm that we wanted to reproduce. So one of the first things that comes into mind, well, let's use the pitch and the threads that's left on the arm. And again, you probably need at least 3, possibly 4 inches. What you do is you make an adapter a collet that fits over the end of your plow plane arm, and you put a radiator hose clamp around it to clamp it and lock that collet in place. It can be made out of wood. Out on the end of that collet, you turn it down to the minor diameter of the screw that you want to make. Put you a cutter in there, just like on the metal cutters here, just like the cutter that's typically used on this apparatus. And using with a fixture to hold the nut over here, you put it in place and you rotate the worn plow plane arm and run the tap through a blank piece of stock in order to make you internal threads that match the pitch of the arm that you're trying to repair. Once you get the nut, in effect, you'll have the nut mounted in this plate like this, that's 90 degrees, and the nut's in here. Of course, the hole size and everything will match the size of the arm. So using the old plow plane iron or arm, the threads, you go in and thread the internal threads, and once you've got that done, now that can be converted into a screw box. That's one option. I'll show you another option over on the lathe. So again, it gives you the flexibility of doing the exact pitch and reproducing and making a nut to match the original pitch and thread size, from the antique plow plane iron arm. Here's a setup that you could put on your lathe to basically replicate and simulate what we were doing in the wooden screw box. What we have here is in the steady rest, we have a piece of Delrin material that's been threaded to match the pitch of the threaded rod. We have the arm that we're going to thread mounted to the chuck, and the black portion that's mounted into the 3-jaw chuck here, this is a Delrin block that holds the V-gouge or the V-cutting threading tool. Now, the thing that's unique about this block, it has been the pitch of the threads that we're turning, the pitch of the lead screw that's installed here, has been laid out, and that block has been bandsawed and planed so that the face of that black fixture is equal to the pitch diameter of the threads that we're turning. I'll remove it in a minute. We'll take a close-up shot of it. Now, imagine using this setup for doing a repair job on a full-size antique plow plane arm. What we would have is we would have the stock or the black portion would be set up the same way. It would have the pitch in the fixture matching the pitch of the threads, and you would have your V cutter or your screw cutter mounted on there on the plate, just like we had on the screw box. So at this point, what we would do is put the we could put the plow plane arm, one good nut that you have, you could install it here in your steady rest, and then put the arm, the threaded arm that you have, run it through the nut that you had, and again out on the end, just like we did in the screw box, we would put a collet and hold it in place with a radiator clamp and have the tap on the outside. This fixture, this piece here, would now be made out of wood or whatever, and you would drill the minor diameter, so you could use, by turning the plow plane arm, the tap would feed through and thread the internal threads of this block, whether it be wood, Delrin, whatever you choose to make it out of. The cool thing about it, if you've only got 3 or 4 inches of thread on your antique plow plane arm, once you reach the limit as far as you can turn it and feed, it's a matter of loosening the radiator clamp, backing the arm out to get back to fresh threads, sliding the steady rest forward, and then reattaching the clamp onto the arm, the tap arm where you're threading the internal threads on the block here. So it's kind of like you never break. You think of this as a half nut, you're never breaking it. All you're doing is repositioning it and moving it back and getting more travel. And by doing that, usually you only have to do it one time, depending on how many good threads you've got left on your arm that you're restoring. Once you tap this piece of wood, Delrin, whatever, and get the internal threads tapped based on the pitch of the arm and the threads, then you can take this out, and you've got 2 options. You can either inlet the cutter like they did on the screw boxes, or you can lay out the pitch, bandsaw this and plane it, and mount your cutter external like on this block. Let's take it out of here and give you a close-up of how that cutter's attached. Again, it's been planed off equal to the pitch. Get things set up there. Pretty much the same setup and the same concept that you had on the screw box. But I like the idea of being able to use the original plow plane arm and nut to thread the internal of this piece here. And again, you've got the option of either dadoing out and putting your cutter in and getting it aligned, or planing that guy off and getting him so that he's got the right spacing, and then you can mount your cutter with a block like this. Okay, what we're going to do now is take one more look at a setup on the lathe. We'll move the camera over to the big lathe, and we'll look at a different operation. Here we have a little different setup. We have a threading V cutter mounted to a piece of keyway stock, and got it in the Loris 2 post holder. And by adjusting the cutter position and the height, we've got it on the sweet spot. We've got the lathe set up for cutting 8 threads per inch, and I've got the lead screw engaged. And typically what I would do if I was going to do a lot of this, I would make me an expanding arbor to go into the rear left side of the headstock and turn it with a wrench. But just for this video, what I'm going to do is grab the pulley on the headstock and manually turn the lathe over. And this is a good way of getting a good view of the cutter as it's going through, and see how the chips are formed on these V cutters. Okay. Again, this is being fed with the lead screw engaged. We're cutting 8 threads per inch. Now, one other option that you have in this configuration, of course, you're limited to what your screw box and your lathe will cut. You can't cut any special threads, but you can, in making an attachment for your Aloris or whatever type tool post holder you have, and mount a small laminate router cutter, and using a V-bit or whatever, you can put it in a laminate router and thread these threads under power as you manually turn it over like I was doing. The other thing is you can make a fly cutter that's shaped, the pitch matches the there we go. You got a fly cutter with your 60-degree pitch. And you can feed and cut internal threads with a router in this configuration here. Just another option, a power option. So let's take this guy off of here, and we'll take it over to the bench and get a close-up view of how this cutter is mounted. A little close-up of the cutter we just got through using. I think, as I recall, this setup or this idea came from archives of a Popular Mechanics, like a late 50, early 60 vintage, when they had an article on wood threading on the lathe. And this was kind of a modified copy of one way they were turning male wood threads on a metal lathe. Here's a setup I have used occasionally, particularly if you've got a material that you need to thread where the V gouge or the V cutter will not cut extremely hard synthetic materials. Here's some alternative ivory, and I've got a cutter in the spindle. I can either use a single lip cutter or a custom ground cutter, and I've actually cut Acme type threads in this configuration. But what we've got here is a lead screw. It was actually borrowed from the wooden screw box. This particular lead screw on this precision green fixture base is left-handed, and by attaching your stock to it and feeding and turning the lead screw, get your cutter position down. The bushing that it goes through on the right has got a ball bearing in it to give it some smoothness and stability, and so you can, by interchanging your lead screw, you can do right-handed and left-handed on this setup. The fixture off to the side to the right is set up to replace the fixture in front of it, and you can mount the plate out of the screw box with the slots that I pointed out earlier. Can be mounted on that fixture, and you could use this setup for cutting wooden threads. There's really no advantage of doing it over on the mill like this. It's just an option that I set up. So with that pretty well wraps it up. I hope I planted a few new ideas or new concepts that you might be able to use in your threading endeavors. With that, we'll wrap it up. If you have any questions or comments, put them on the in the comments field, and I'll try to answer them, get back to you. And hey, if you liked the video, give me a like. If you hadn't already subscribed, please subscribe. I've got several more videos planned here in the near future. I think the next one I'm going to do is on making hinges. I've got a really killer little fixture I made years ago for making small hinges. I think you'll enjoy that one. So with that, we'll call it a wrap. Have a nice day.